Good morning. I am Dr. A. Kalai Selvi. Today I present the topic alpha beta pruning. Alpha beta pruning is a modified version of minimax algorithm. It is an optimization technique for the minimax algorithm. As we have seen in the minimax search algorithm that the number of game states it has to examine are exponential in depth of the tree. Since we cannot eliminate the exponent, but we can cut it to off. Hence, there is a technique by which, without checking each node of the game tree, we can compute the correct minimax decision, and this technique is called pruning. This involves two threshold parameters, that is alpha and another one is beta, for future expansion. So it is called alpha beta pruning. The two parameters can be defined as, the two parameters are alpha and the beta. Alpha, the best, that is highest value choice we have found so far at any point along the path of maximizer. The initial value of alpha is minus infinite. Beta, the best, that is lowest value choice we have found so far at any point along the path of minimizer. The initial value of beta is plus infinite. The condition for alpha beta pruning is, the main condition which record for alpha beta pruning is alpha greater than or equal to beta. The working of alpha beta pruning. This is the tree structure. In the root node, alpha is equal to minus infinite, beta is equal to infinite. That is the maximum level. Then the next choice is minimum level, and the next choice is maximum level, and the final is the terminal node. That is the working principles are, first step. At the first step, the max player will start first to move from node A, where alpha is equal to minus infinite and beta is equal to plus infinite. These values of alpha and beta passed down to node B, where assigned alpha is equal to minus infinite and beta is equal to plus infinite. Then node B passes the same value to its child D. Okay, the next step 2. At node D, the value of alpha will be calculated as its turn for maximum. The value of alpha is compared with firstly 2 and 3. Then the maximum of 2, 3 is equal to 3 will be the value of alpha at node D. And node value will also 3. That is the maximum value is 3. So the node value is 3. The next step, now algorithm backtracks node B, where the value of beta will change as this is a turn of minimum. Now beta is equal to plus infinite will compare with the value of subsequent node value, that is minimum of infinite comma 3, that is equal to minimum value is 3. Hence at node B, now alpha is equal to minus infinite and beta is equal to 3. This is the structure. That is alpha is equal, next level, that is first level maximum, then the minimum level alpha is equal to minus infinite and beta is equal to 3. Then next level, then the next step is at node E, maximum value will take its turn and the value of alpha will change. The current value of alpha will be compared with 5. So maximum of minus infinite comma 5 is equal to 5. Hence at node E, alpha is equal to 5 and beta is equal to 3. Where alpha is greater than or equal to beta, the condition is satisfied. So the right successor of E will be pruned and the algorithm will not traverse it and the value at node E will be 5. Then the next step next step algorithm again backtracks the tree from node B to A. At node A, the value of alpha will be changed. The maximum available value is 3 as maximum. That is minus infinite maximum of minus infinite comma 3 is equal to 3. And beta is equal to plus infinite. These two values now passes to right successor of A, which is node C. At node C, alpha is equal to 3 and beta is equal to plus infinite. And the same value will be passed on to node F. This is the structure. That is alpha is passed on. That is next level, F level. Then the next step at node F, again the value of alpha will be compared with left child, which is 0, and the maximum of 3 comma 0 is equal to 3, and then compared with the right child, which is 1, and the maximum of 3 comma 1 is equal to 3. Still alpha remains 3, but the node value of F will become 1. Then the next step, node F returns the node value 1 to node C. At C, alpha is equal to 3 and beta is equal to plus infinite. Here the value of beta will be changed. It will be compared with 1. So, minimum of alpha comma 1 is equal to 1. Now, at the node C, alpha is equal to 3 and beta is equal to 1. And again it satisfies the condition alpha greater than or equal to beta. So the next child of C, which is G, will be pruned and the algorithm will not compute the entire subtree G. So this is the structure. That is, the G will not continue to next level. Next step, C now returns the value of 1 to A. Here the best value of A is maximum of 3 comma 1, that is equal to 3. Following is the final game tree, which is showing the nodes which are computed and nodes which has never computed. Hence the optimal value for the maximizer is 3 for this example. Then the next one is game strategies. In these game strategies, 3 strategies, that is dominant strategy, pure strategies, and the mixed strategies. Then strategies means it is a complete approach for playing a game, which moves is an action taken by a player at some point during the course of the game. That is, first one is dominant strategies. One strategy is better than another for the same player irrespective of other players' game. Pure strategies. It is the complete approach of a player's game plan. Mixed strategies. Randomly, the player can choose a strategy based on probability assigned for any strategy. The next one is backward induction. Optimal actions are executed by backward reasoning. Thank you.